Oi, bom dia a todos. Hoje teremos mais uma apresentação, uma palestra do Simpósio Internacional do Programa de Pós-Graduação de Geotecnia da EESC. Como recebemos frequentemente professores do estrangeiro, professores visitantes, então a nossa ideia é aproveitar a experiência deles, né, e mostrar para os nossos alunos da pós-graduação e para outros um pouco da geotecnia em outros países, né. Essa é a segunda apresentação do professor Pankaj Sharma, da Índia. Ele é um professor visitante, que está como pós-doc no nosso programa, né. Dia 29 teremos um professor visitante da Universidade de Grenoble, da França, ainda 29 de tarde. Então, deixo com vocês aqui que aproveitem agora a experiência do professor Pankaj, né? Um pouco da geotecnia da Índia, ele vai falar para vocês. Professor Pankaj, thank you very much for the presentation, and you are free to start and
Okay.
welcome. You have already a microphone? Or?
Yeah.
Okay.
It's working?
It's working, his microphone, no?
Okay.
Thank you very much, Pankaj. You're welcome.
So, should I start?
Yes.
Okay. So, very good morning, one and all present here. My name is Pankaj. Bonjia, namaste to all. So, thanks for giving me the opportunity, Professor Christina, and I would also like to thank University of São Paulo. So, my topic is the application of helical soil nail, and it's a case study on a Ktropi landslide. So, let's begin with the very basic. Yeah. So here is the outline summary of the presentation. First of all, we'll discuss about the introductory session of the soil nail and then advancement in the soil nail. Then we'll discuss the mechanism of the soil nail, and then we'll come to the practical application of the soil nail. So here is the introduction. So what is the soil nail? It's a passive reinforcement element. So used to introduce in the soil mass just to increase the shear strength of the soil. So this technique was derived from the new Austrian tunneling method. So initially this method was used for the rock bolting. So from there this technique was derived for the case of soil. So it's a top-down approach, which means when we start constructing a nail wall, so we work from top to bottom. So different kind of nails we have. Normally these are of steel, and carbon fiber rod is also there, glass fiber reinforced polymer rods are there, and for the installation of nail we used to drill a hole from top to bottom, then one by one we install a nail into the gallery along with the grout. So this was the conventional approach of the installation of a nail. So what is the need of soil nailing? So for example, we have existing structure is already there. So we cannot construct a retaining wall at the bottom of that structure. So in order to perform the operation like reinforcement on a existing structure, we use this technique, that is soil nail, and it's very easy to install on an existing structure. Also, for example, people think if we have a retaining wall over here, so what is the requirement of the soil nailing? So for example, if you see here, we have the retaining wall, but retaining wall can provide support to the outermost periphery, but it cannot reinforce the inside soil mass. So in order to reinforce the soil mass, we use this technique. Also, for example, if you see, for the construction of tunnel, we required to reinforce the soil mass without increasing the area. Otherwise, if we used to apply retaining wall, it will take much space. So here, without changing the strata, we just reinforce the soil mass. Also, for the surface at the top level, we can easily reinforce the soil mass without changing the geometry. Also, for retaining, also the use of using the soil nail, we can we can reinforce the soil mass without disturbing the soil condition. So that's the need of soil nail. Now where we can apply, so application of the soil nail, we can use it for the roadways, for the retaining wall, embankments, and any kind of problematic slope. So let's discuss the element of soil nailing. So we have the very important element, if you see in the figure, that is tendon, which is going to reinforce the soil mass. Now the tendon was installed along with the grout mass, and here is the initial facing, which is sometimes we call this facing as a temporary facing, and then after installing the nail along with grout and applying the bearing plate over here, and after shotcreting we will apply the final facing. We will discuss this step in detail. Now we have the function of facing, why the facing is required. Sometimes people may ask that we have a rod to reinforce the soil mass, so what is use of facing? So now facing normally help us to provide the overall stability first of all. Second is it helps to stop the erosion and the weathering. Second, it helps to the even distribution of the load. You can say uniformly distribution of the load. It helps in uniformly distribution of the load, and it will also give a better aesthetic to the nail wall. So we have different type of facing. First is temporary facing. As the name indicates that temporary facing is the initial facing. We used to apply using the wood, we can use the leather, we can use the PVC, and some kind of biodegradable material like bamboo sticks. And in the construction of steel, we use wire mesh sometimes. And the permanent facing is the final facing we used to apply at the last stage, normally with the help of bricks and the different mold or different shotcrete. So now the various design consideration, also the facing provide the load resistance and overall stability to the structure, and after the final stage we just use a final facing using it's just like a sandwich. We have an initial, then we have a nail wall, you can say bearing plate, and then the outer facing, which is final stage. So various steps which include in the installation of nail. First of all, we used to cut a soil slope up to 1 to 1.5 meter. You can say 3 to 5 feet, so which is unsupported. So after excavating, this is top, I have already discussed that this is top down approach. From top we cut the surface up to 1 meter, then we used to build there a gallery which cause certain disturbance in this area, but we have to adjust the speed of installation accordingly. So after making a hole over here, we install a nail along with the grout. Also we apply the drainage, strip drainage to remove the excess water from the soil mass. Then after this we have the shotcrete over the mesh. That is here we can complete this phase of initial facing. After this we have to repeat this operation for multiple times for subsequent level or up to the height of slope, and then we apply the final facing. So this is the basic procedure to install a nail. So here if you see, we have already installed the nail over here, and already installed the nail, and this is the temporary facing. We can stop our function over here, but if you think the structure over the slope is important or it's significant to us, we can apply shotcreting over here and then different stone and the retaining wall or for the better look. otherwise it's enough, it's also retaining your slope. So after that stage we apply the shotcrete from top to bottom like this. Here the top down approach is clearly visible. Now after completing the shotcreting operation, the wall looks like this. Further you can make a better aesthetic by applying different blocks at the outermost periphery of the wall. So different conventional nail people use in the history. Initially people start from a bamboo stick, then here's a glass fiber reinforced polymer, and here's a helical rib rod and the rod with a rough surface. These were the initial soil nail the people used in the past. So we have to discuss about the favorable conditions. So normally the dense sand for ideal condition for the soil nail is considered as dense sand, which is not always there, but it is considered as most ideal fit, you can say most favorable condition for the soil nailing. However, soil with boulder and with high water table have a problem, and also soil with, you can say, cohesionless soil, it's also perform poor in the cohesionless soil. Also sometimes the freezing effect and seismic affect the soil nail significantly. So now we have to discuss about the problem in a soil nail. So if you see, we have a different problem, because when we install a nail there is a two type of interface, soil to grout and grout to nail. So there is a problem between the interaction with two different interface. Also under water table this interaction also will give you the worst result. Further, with the water table, with the high water table, the grout cement water cement ratio get changed. So these are the problem. During the installation of these nail, there are the soil spoil there, so which is again the problem. So these are the list of problem which we discovered in the convention soil nail, that is management of soil spoil. Also during the installation of nail, there is a huge disturbance in the existing periphery. So in order to incorporate this problem, so ultimately these all problem what did, there's a decrease in the pull out capacity of a nail. So why we are discussing about the pull out? After discussing this much of problem, there is a resulting decrease in the pull out capacity. So why only pull out? So pull out is the property of a soil, not the material, so which depend upon the soil type, overburden pressure, installation method, and the grouting procedure. So what is pull out? So in a soil nail wall, we have three kind of resistance which incorporate or which provide a strength to the soil mass. First is facing resistance, second one is tensile resistance, and the pull out resistance. So why I am talking about the pull out? Just because there, if you see, if we use better material, for example, for facing I am using steel. Similarly for nail I am using better quality of steel. So we can improve the facing resistance and the tensile resistance. So which we can control this resistance easily by improving the material quality. However, the pull out resistance, for example, if pull out nail is poor in pull out, but you are using better material, still your structure get fail. You understand? This is very important to understand. If you are using better facing, better material for the tensile resistance, still your structure get failed if the pull out resistance is poor. Understand? That's why it's very important. Now I will discuss what is the pull out resistance. If you see, in a soil slope there is a two zone. When we have a retaining wall or a soil mass or a existing slope, it will show you some part of soil is bit disturbed, which is called active zone, and the other part is stable one. You can, that is bit intact from the other, which is called the passive zone. So when we install a nail, we try to fit the nail into a passive zone, because when there is some disturbance in this area, so this element start working. Just because nail is a passive element, and after this, when there is a disturbance, this pull out resistance start working. We have, okay, so in order to avoid this problem, we have introduced another concept of helical soil nail, which idea was copied from helical pile and the helical anchor. So as you people are from the helical pile background, you already know the history of helical pile and the anchor. So it was started in England for a light horse to provide better uplift capacity to the foundation. So these are the different component of a nail: the shaft, the helix, and here using helical soil nail, what will happen? It will reduce the disturbance when we install. For example, when we were installing a conventional pile, so what will happen? We just make a hole, we remove the soil, then we put a nail and put a grout. But for the case of helical soil nail, we are just installing a nail like a screw. There is no disturbance or negligible disturbance in the existing geometry. Also, this process of installation is very quick using helical soil nail. So here is the load transfer mechanism. Also, you can see when we were using conventional soil nail, however, conventional nail is most common nowadays in the field, but here helical soil nail is the advancement in the field of soil nailing. So if you see, the conventional soil nail only provide you the shaft resistance. However, for a helical soil nail, we have two kind of resistance. First is resistance because of the shaft, which is same, and second one is the bearing resistance. So I have already discussed that pull out is very important. So when we use this helical soil nail, it will increase the pull out capacity of nail just because of bearing resistance. So when we install a nail, it acts as a fastener between active and passive zone, and when there is some disturbance in active zone, this passive element start working and it provide a shear stress in opposite direction to the disturbance, and resulting your soil mass get intact. So there is a question always people might ask that what is difference between helical pile and helical nail. So normally when we use a helical pile, it acts in a one zone, in an active zone. So it offer a uplift capacity, it offer a resistance against uplift capacity. However, the nail is a passive element and installed between two layers, that is active and passive zone. However, we have a active zone here only, but here we have an active zone and the passive zone, and it offer different resistance when there is a displacement in this section. So this is very basic difference between the helical nail and the helical pile. Also, this is a typical geometry of a helical soil nail structure. This structure is installed at the angle of 10 to 15 degree, which is considered as the most optimum angle for the installation. However, you can install the helical soil nail from 10 degree to 25 degree. This is a range for the better result. However, sometimes people may install at 0 degree also. But this is the optimum angle as per the FSI and FHWA 2015. There is a code for the installation of soil nail, and this zone or you can say length of nail. How one can decide the length of nail? It's about 0.7 time h to 0.8 time h. So what is the h? H is the height of the slope. So this is the typical slip circle. So you can use the nail up to 0.8 time h. Now this is a question that we can use all the nail of same size. Yes, we can use. Also, but in order to save money, or you can say for the economy purpose, we just use the top nail of bigger size, then we curtail this size, and for last one we use the smaller nail, just because you if you see slip circle form like this. So the top most nail has a bigger length comparative to this length. However, you can use equal nail also, but for the purpose of economy. Now I have already discussed the case earlier, the failure concept, that how a nail can fail, that is internal failure. Internal failure include, that is pull out resistance and the nail, if nail get fail. Facing failure, if facing get fail, in that case the slope will fail. How facing can fail? During the bending, you can say the flexural failure or the punching shear failure. And last failure, which is very important, that is external mode of failure, if there is a sliding, if there is a base failure, or global instability is there. So these are the case for the failure. So different study was conducted by different researcher, and also execution was done by different people in last 20 years. So as per from which most of the work is has been reported by researchers between 2000 to 14. So this was the work for conventional nail. However, for helical soil nail, the first study was reported in 2008, and from which most of the work was reported in year 16 to 20 as per Web of Science. Now if we required a pull-out test, so what are the laboratory tests for the calculation of pull-out? So we have a tank. In order to calculate the pull-out capacity, we simulate this condition over here. We consider that there are number of assumptions are also there. So in order to calculate the pull-out capacity of particular soil and particular nail sample, we just use the soil sample inside this tank, and we use our specimen. You can use your model specimen, and by applying some force at if the soil sample is the sample which is at your site, you just fill the tank with the sample by maintaining equal relative density and the field condition. So then apply the force over here. When there is a displacement of 30 mm, up to 30 mm is considered as the pull-out value. After that, if further you may get the max value of force, but still you will consider the pull-out value up to 30 mm. So these are the literature conducted by different researchers. Different laboratory test was done by different researchers to calculate the pull-out capacity. So for example, from these tests you may calculate, for example, here researchers had reported under different overburden pressure, the angle of inclination is considered between 10 to 20 for installation, and the pull-out, it will give the better result. So these kind of parameter you can check from the pull-out test and the apparatus. So now we has a field study. So that is a field application of helical soil nail. It's a study on a location called Ktropi, which is in India. So in this landslide was approximately 1 kilometer landslide, in which it was a debris flow which occur near Ktropi is a place, and Mandi is the city in a state of Himachal Pradesh in India. So where this landslide swept away two government buses, or you can say transport buses, causing 47 fatalities. So the stretch was 300 meter. If you see the news report in that time, it was a massive landslide in this area. So we have provided this solution to this slope. If you also this area is very disturbed. This is another landslide in that location, so near to that location. So we have suggested the solution or the remedy to stop these landslides. So here, if you see, there is a poor shear strength in the soil of this kind of slope. So we have tested for this kind of site. We just, if you see, there is a less boulder in this kind of soil and loose and poor or problematic slope where a number of people lost their life every year. These are the video from Himalayan region of India. So for this reason we have provided, however we cannot provide nailing to everywhere, to every slope. We can reinforce the every slope using hubs, using different kind of hubs with long roots. But for example, we have an important structure over here. We have an important building there, and we have national highway there. So for that purpose, we can use soil nailing, just because for important structure we cannot use only hubs. Understand? So normally people suggest you if we have the hubs, if we have the plants to stabilize the slope. So why we are using nailing? Just because if we have an important structure like hotel, hospital and important structure, for that we use soil nail. So in this case study, we divide the whole slope into 3 sections, that is upper, middle or lower, and we have collected also in that slope it was very difficult to conduct some SPT or something. So that's why we have just collected the sample using the core cutter method, using open pit method. So like this we have divided the slope. So we have collected total 27 sample from different depth, that is 0.5, 1 meter and 1.5 meter, in order to just check the property of the soil. Also for soil nailing, it become very important to test for chemical. For example, if harmful chemical are there or corrosive chemical are there, so it will cause problem to the soil nail. So we have conducted a test for chloride and sulfate and the pH value, which was in the permissible limit as per the FSWA code, which is the code of soil nailing, Federal Highway Authority, which is a code from the US government. So these are the sample we have tested as per the respective codes. If you see the values, well, for chloride it was less than 100, for sulfate it was also less than 200, and the pH value was also in the permissible limit. So then we proceed using the FEM analysis using Plexus 2D. So for that we have not considered the whole slope. So just we have picked the strata that is 30 meter above from the road and 30 meter below from the road. However, the landslide was 1 kilometer long, so we cannot reinforce the whole area. So just we pick a small stretch to reconstruct that area. And the benching, for example, this geometry we have used number of trial and error method to fit in order to get better factor of safety. Also we use the benching as per IS code. This is a code for landslide, that is Indian Standard Code, which offer us that if you divide a bigger landslide into bench or in a segment, by different segment, you can achieve better factor of safety. So we use that procedure by dividing the whole slide into different segment. Here is the input parameter that we have used. So for example, for helical soil nail in plexus, we have used the plate element, and here are the property of elastic modulus and the different property for a steel bar, and the different soil property we have calculated using the geotechnical analysis of the soil sample. These are the parameters that we have used in the nail. That, for example, length of nail we have used 6 meter. As per just because we are using slope, we have divided the slope into 10 meter height. If you see, the section is of 10 meter or 30 meter above, 30 meter below. So therefore the nail length was considered between 0.6 to 0.8 times h, and the inclination angle we have considered up to 15 degree, and the spacing 1.1. So these are the different parameters we have used in the plexus 2D. Also, we have calculated the theoretical factor of safety using the soil nail. So there is a formulation given by FSI and the FSWA, different code of soil nailing. So we have put the value of this is a surcharge weight, this is a frictional interface friction. So by putting all this value, when we install a nail, for that theoretically we have calculated the factor of safety, which is 2.54. we get the value 2.54, which is greater than 1.5. 1.5 is considered as global factor of safety. Also, when we analyze the slope into the plexus 2D, so for unreinforced slope, when we were analyzing this slope, we found a message at the end, soil body seems to be collapsed, which means if you receive this kind of message that soil body is seem to collapse, it means the factor of safety is less than 1. So it means there is a slide in your slope. So further, then after adding the plate element, or you can say nailing into the soil mass, we achieve the factor up to 1.55 using the reinforced slope using the soil nail. Further, we have tried another trial for the geometry. We just remove the top soil, the surface, the factor of safety just increase up to 1.6, which report if we have a overburden, large overburden, yeah, more overburden over the top surface, it will give you less factor of safety. So when we are trying to execute a operation, so we can reduce the weight of the soil from the top surface so that we can achieve more factor of safety. So here are the result we found from the plexus 2D. Also, we have found when we analyzed the slope with unreinforcement or without nail, the displacement was reported 54% more than a slope with a nail. So if you see, there's a 54% of displacement was stopped by using this nail. So here is the site. So now we have concluded our study over there. Now government body is going to apply the soil nail in that area. So here are the visual of that area, but this is somewhere they are applying conventional nail, somewhere because they are also applying helical nail for the first time, so they won't take the risk of helical nail just because it's a new in the field. So after applying the nail and the shortcut, it's look like this. So from the concluding remark, we have the different conclusion that by using a soil nail, we can reinforce a slope. And if you see in the Ktropi slide, when we have installed the nail, the factor of safety got increased up to 1.5 or greater than 1.5. That is the global factor of safety, and without the nail the factor of safety was less than 1, and also the deformation for slope was reduced from 130 mm to 60 mm from after installation of the nail. So thank you very much. Dhanyavad.
Thank you very much,
Thank you.
Professor Pankaj, for the presentation. Very interesting. In
Thank
this
you.
case, very tragic case in Himalaya, Ktropi.
Yeah, it's
Yes.
Ktropi in Himalayas. Yes.
It's very usual. It's very frequent. This kind of
Yes, in
accident.
that area it's very
That's
frequent.
very-
Yes.
So the use of soil nail can improve the
Yeah.
can reduce the risk of the people.
Yeah.
at the
For
sources.
example, if we have an important structure, then we can use the soil nail. However, Himalaya is very big. You cannot stabilize every slope with nailing. So you can use different herbs with long root also. So even people are doing pull-out test of different herbs. That is geo-environmental, by using geo-environmental studies, that people are using different herbs or plants with long root and having less unit weight of that trees. So, but if we have an important structure, we cannot prefer that herbs. So that's why we, for important structure, we used to install the nails.
Okay. I have one question before I pass the question for the others. You said that you did some chemicals test on the soil in the laboratory.
Yes.
Yes, pH and the sulfate, etc. Is for the corrosion problems, corrosion of the steel, corrosion in the nails.
Yeah, corrosion. Yes, just
Corrosion.
because sulfide and chloride create a corrosive problem. There's a rusting problem in the nails. So also we used to apply zinc layer
Zinc.
over the nail, or galvanization is the process is called galvanization. But still, if there is a excessive chloride or sulfide is there, so that cause a significant problem to the soil nail structure.
Yes, thank you. So I have some students here. Professor, do you have some questions? Okay, Amanda, you. You ask in Portuguese and I can.
Yeah, sure.
Aparentemente, as estacas helicoidais foram usadas de forma convencional, pelo que eu entendi. É possível usar com injeção de cimento? Estacas injetadas?
Amanda asked that we in India use the helical piles, the conventional helical piles, not injected helical piles as we started to use it now in Brazil. So is it possible to improve the performance? What do you think if you can inject the helical nails?
For normally, what the difference, major difference is the diameter. If we use little bigger dia for the nail, normally the diameter varies from 30 mm, maximum diameter is 80 mm, dia of shaft. So if we use bit bigger dia with hollow section, so we can use the injected, we can apply injection to the helical soil nail also. Yes.
Okay, thank you, Bankashi.
Thank you.
Another questions about plaxes. We have some people specialized in plaxes here.
In this case, we have a large debris flow.
Yes.
How difficult is to determine the soil input parameters for the numerical model?
Yeah, it's very much difficult. For example, we cannot perform SPT on that slope. So just for my case, I just use the core cutter method or open pit method, and just collected the sample from 0.5, 1 meter and 1.5 meter depth, and it was not that much deep. I knew that, but what not difficult to go much. So after collecting the soil sample, we we use to put into the plastic bag and carry to our geotechnical lab. At our geotechnical lab, we use the DST and the triaxial shear test to calculate the shear strength parameter of the soil, and also the basic basic test like grain size analysis. You can analyze the basic property of the soil using the basic geotechnical. For example, the Atterberg's limit and the density of soil, like these tests. Yes.
Okay, thank you.
Thank you.
More questions? Oh, Leticia?
Thank you for the presentation. I have a simple question. I was thinking about the access of the equipment after for the stabilization. How difficult it is to perform the soil nail?
Yeah, when it comes to conventional soil nail, it's bit difficult, just because when we use the drilling operation, we apply the drilling operation. So there is a disturbance in the periphery, and sometimes the drill hole gets settled on and cause the collapse in the area. So it was a difficult, and this required very smooth drilling or with less speed. However, for the case of helical soil nail, it's not like that. It's just we are installing a nail as a screw action, using a screw action. In that case, we did not remove any kind of soil, and that just cover the void of the soil and make your mass bit dense. So it's easy to perform helical soil nail, but till date people are using less soil nail, because this is the field where advancement is going on. However, conventional soil nail is people are doing from very beginning, from last 20 years. So it's well established in market, and you may find different equipment for the application of conventional soil nail. Yeah, thank you.
Thank you.
Thank you, Leticia. You think that in this solution have less disturbance,
Yes.
compared to the conventional
Yes, conventional
soil
soil nail.
nail?
And also for conventional soil nail, we required pressure grotting with controlled pressure. But if we are using helical soil nail without injection, because it provides enough resistance,
Yes.
so you can save the cost of cement also, and you can say it's a sustainable way to reinforce a slope, just because we are not using cement, and we are using less power, just because for conventional soil nail, first we drill a hole, when we put a rod, we use a cement. But for conventional soil nail, we just install a nail by a screw action. So it's better than a conventional soil nail.
There's more equipment you use there to install the nail. The helical nail is small equipment.
For conventional soil nail, I think we require more equipment, just because we required drilling machine, we required pressure grotting, or we required nail. But for the helical soil nail, the only we required an installing machine.
Okay.
Yes.
Thank you.
Thank you.
So, no more questions? Oscar?
At first, congratulations for the presentation.
Thank you.
My question is about the soil helical pile.
Yes.
In a parametric study, which parameter has more influence in its behavior? Maybe the shaft, the space between the plates, the diameter of the plates. Which of them has more influence?
It's as per best of my knowledge, it's a bearing resistance of helices, the helical plate. Just because when we have a plate, helical plate is there and shaft is there, so in that case the resistance offered by shaft is negligible. So only the resistance which is offered by the helices of the pile or a nail is a predominant factor, or in which offer the resistance to the uplift capacity of pile and the pull out capacity of a nail. Yes.
Thank you.
Thank you.
One more questions, or I think no more questions. So thank you very much, Pankaj. Namaste.
Thank you. Namaste.
It was very good presentation, something new for us and very interesting. So many thanks.
Thank you very much.
And now I will just speak in português, né? Vamos finalizar a nossa apresentação, professor Pankaj. E até a próxima, dia 29, temos ainda uma outra apresentação, 29 à tarde, professor Daniel Dias, da Universidade de Grenoble. Tá? Então, será nosso próximo evento com os alunos da pós-graduação aqui. Tá? Bom dia a todos.
Thank you.